This is lesson 5 in the Ultimate Factoring series. We're now transitioning into trinomials, specifically trinomials of the form x squared plus bx plus c. Just a reminder, trinomial means it has 3 parts. That's what the tri comes from. Most of the lessons up to this point dealt with binomials. That was things with 2 pieces. So first, factoring trinomials is similar to reverse FOIL. And we'll see how that works out in just a few minutes. So when we have x squared plus bx plus c, keep in mind that b and c are numbers. It could be x squared plus 2x plus 3 or x squared minus 4x plus 5, different things like that. So the question we have to ask when we're trying to figure out how to factor these is what numbers would multiply to equal c and add up to equal b. And you'll see, again, we'll see why in just a minute. But what numbers multiply to equal c and add up to equal b? So you have to figure out what numbers will multiply to be the last number and add up to the middle number. And just like you could check your answers on some of the other forms we've done, you can check your answer here by doing FOIL. So let's look at our first example, and I'll try to help you see how this is related to foiling and how we follow that rule regarding multiplying to be the last number and adding up to the middle number. So our goal here is to have 2 terms in parentheses. Now, since we have x squared up front, we know we're going to have x and x in front here, because x times x is x squared, so that's going to give us that term we need. But now we've got to figure out what numbers to put here and what sign to put in between them, whether it's going to be plus and minus, minus and plus, both plus or both minus. So here's how I recommend you set this up. Somewhere off to the side, give yourself 2 blanks and put times. And we know that we want it to multiply to equal 4. We want it to multiply to equal the last number. And we want those same 2 numbers to add up to equal positive 5. So what I would recommend is you write down all the factors of 4. In other words, what pairs will multiply to be 4? Well, that would be 1 and 4, or 2 and 2. So both 1 and 4 and 2 and 2 would work in there. Both of those would multiply to equal 4. The question is, will they add up to 5? Well, 2 and 2 is not 5. 2 plus 2 does not equal 5, but 1 and 4 does. So we see that this works. 1 times 4 equals 4, and 1 plus 4 equals 5. And since they are both positive, that means we'll put pluses in between. So that is our final answer. On most problems from here on out, I'll stop there because that is the answer. But I want to try to help you see how this is related to foiling. So remember, FOIL stands for first, outer, inner, last. That's what the FOIL stands for. First, outer, inner, last. Because when you have 2 binomials you're trying to multiply like we do here, x plus 1 is a binomial, x plus 4 is a binomial. To multiply them, you FOIL. So I do f, the first terms, x times x is x squared. Then I do the outer terms, x times 4 is 4x. Then I do the inner terms, 1 times x. And then I do the last terms, 1 times 4 is 4. And you can tell there, hopefully, that there are like terms here in the middle. They can be combined. So we get x squared plus 5x plus 4. So this does a couple things. First, it confirms we have the correct answer because we got back what we started with. But hopefully it shows you how this multiply to be the last number and add up to the middle number works. Because we have x times 4 and 1 times x as our outer and inner, what we got right here, those add up to be the middle number. So the 4 and the 1 end up getting multiplied by x and then added together to equal the middle number. And then the last numbers, the 1 and the 4, get multiplied together, the red line, to equal the last number. So the first terms make, I'll put it this way, this is our first term, this is our outer, this is our inner, and this is our last. So the way it turns out, the first terms multiplied give you the first term. The last terms multiplied give you the last term. You can see that here and here. And then the outer and the inner term get combined to equal the middle term. So often they call the O and the I the middle terms because they tend to get combined into a single term. So the first terms equal the first term, the last term equal the last term, and the two middle, the outer and the inner, add up to be the middle term. Okay, now let's try x squared minus 6x plus 8. Again, we have a trinomial, so as soon as you see the fact that we have three terms, you can pretty much conclude, okay, it's going to be two binomials being multiplied together. And because the first term is x squared, we know to put x in front of both. Again, x times x will give us the x squared. So now we come over here, we need to think what will multiply to equal 8, because that's the last number, and what will add together to be negative 6. So you do need to carry the signs over with them. In the first example, they're both positive. In this example, the 8 is positive, the 6 is negative. So I need to think of what multiplies to be 8. Well, that would be 1 and 8, or 2 and 4. Well, 1 and 8 multiplies to be 8, obviously, but I don't think there's any way to make a 6 out of it. You can make a 9. You can do 1 plus 8 is 9. You can make a 7. 8 minus 1 is 7, but there's no way to make a 6. So good news. 2 and 4 can make a 6. So we'll do 2 times 4 is 8, and 2 plus 4, well, 2 plus 4 is positive 6, so to make it negative 6, we're going to have to make it a negative 2 and a negative 4, and that still works for us, because negative 2 times negative 4 is positive 8, and negative 2 plus negative 4 is negative 6. So over here we put in negative 2 and negative 4, and we have our answer. I'm going to go ahead and FOIL this one, and then probably won't do it anymore after that. So F for first terms get multiplied together. O for outer terms get multiplied together, negative 4 times x. I for inner terms get multiplied together, negative 2 times x. L for last terms get multiplied together. That's a positive 8 because it's negative 2 times negative 4. And we got back the same thing we started with, so we know our answer is correct. X minus 2 times x minus 4. And one thing you always want to look out for, the first rule in factoring is really to go back to what I taught in lesson 1, and that's to look for the greatest common factor. You need to make sure that there's not a number or a value or a term you can pull out in front because every term has it in common. So the first three examples, there haven't been any, but we need to be on the lookout for that. You look at this example, there's nothing that all three of these terms have in common. And it does have to be all three of the terms to be able to factor it out. So the first two terms here, x squared and x, do have an x in common, but the 20 doesn't have it, so we don't want to do that. We only want to factor out something that all three of them have in common. So like I said, this example, x squared, negative 6x, and 8, there's nothing all three have in common other than 1. X squared plus 5x plus 4, there's nothing all three have in common other than 1. So there was nothing to do there. We could go straight to the part with the parentheses where we change it to two binomials. So we'll go ahead and do that here. We'll have x and x because we want to multiply to x squared. Then we got to figure out what multiplies to equal negative 20 and what adds up to negative 1. Because negative x, there's an implied 1 there, so the middle number is negative 1. So let's think of all the things that can multiply to be 20. 1 and 20, 2 and 10, 4, and 5. You can use your calculator to help you figure out these factors if you need to. For me personally, I always just start with 1. Say, okay, 1 times what gives me 20? 20. Then I go to 2. Okay, 2 does go into 20, so 2 times what gives me 20? That's 10. Then I think, okay, 3 does not go into 20, so I skip that one. And then 4 does go into 20. 4 times 5 is 20. And then 5 I've already used, so I can quit. Once you get down to a number you've already used, then you don't have to go any farther. I need to think which of those numbers can help me add up to a negative 1. Well, the only pair of numbers here that could possibly produce a 1 would be 4 and 5. So we need to think carefully about what signs we want to put on here. The fact that they need to add up, multiply to be negative 20 tells me one of them has to be negative. Because for two numbers to multiply together and be negative, one has to be negative and one has to be positive. So you can guess and check a little bit if you need to. Think, okay, what if I do a negative 4 and a positive 5? Well, negative 4 plus 5 would be a positive 1, so that doesn't work. So let's try, sorry about that, a negative 5. 4 plus negative 5 is negative 1, so that works. And 4 times negative 5 is also 20, so we'll have x plus 4 and x minus 5 as our answer. Next example, x squared plus 4x minus 21. Double check, is there anything that all three terms have in common? No, nothing other than 1, so there's nothing we need to pull out. We set up the two sets of parentheses, put x's in front because x times x will be x squared. Then we need to figure out what will multiply to equal negative 21 and add up to positive 4. So 1 times 21 is obviously 21. 2 doesn't go into 21. 3 does. 3 times 7 is 21. 4 doesn't go in. 5 doesn't go in. 6 doesn't go in. 7 does, but we've already used it, so we're finished. So we need to figure out which of those pairs of numbers we can use to add up to 4. Well, that would appear to be the 3 and the 7. And just like the previous problem, since they need to multiply to be negative 21, we know one of them has to be negative. Oh, I'm sorry, I don't know where I got those 4s. It should be 7. There we go. So we need one of those numbers to be negative. Since we want it to be a positive 4, it makes sense that we want the bigger number to be positive, so the whole sum is positive. So negative needs to go with the 3. And that does work. Negative 3 times 7 is negative 21, and negative 3 plus 7 would be positive 4. So we put these in our parentheses as x minus 3, x plus 7. And don't feel like you have to get it right the first time. If you're not sure where the negative goes, just try it, and then see if it multiplies and adds to the numbers you want. If it does, great. If it doesn't, try the negative somewhere else. X squared minus 11x minus 12. Again, there's nothing that all three have in common, so we don't have to worry about pulling out a greatest common factor. I set up the two parentheses, put x's in front. I need something that multiplies to be negative 12 and adds to be negative 11. Okay, 1 goes into 12, 1 times 12. 2 goes into 12, that's 2 times 6. 3 goes into 12, that's 3 times 4. 4 goes into 12, and I've already used it. So that's all the pairs that multiply to be 12. I want to add up to negative 11. And that has to be the 1 and the 12. There's no way to make 2 and 6 add up to an 11 or 3 and 4. So it'll be 1 and 12 for both. The question is what signs? The fact that we're trying to multiply to be negative 12 tells us there should be one negative and one positive. So just to go further with what I said earlier, if you're not sure where the negative goes, just try something. So let's just try it with the 1. Negative 1 plus 12 gives me positive 11. So that's not right. Let's do 1 plus negative 12. That's the same as 1 minus 12, which is negative 11. So that works perfect. We have a positive 1 and a negative 12. and they both multiply to be negative 12 and add up to negative 11. Alright, thanks for bearing with me this long. I know this is difficult, or this is getting long, but this is a super important step in the factoring process, and I want to give you as many examples and help you firm this up as I possibly can. So again, there's nothing that all three terms have in common. You always want to have that in your mind. Is there greatest common factor I can pull out? There's not here. You'll see an example of that in a bit. So we put x and x in front, so they multiply to be x squared like we want. We need two numbers to multiply to be 22 and add up to negative 23. Okay, so 22, 1 goes into it, that would be 22. 2 goes into it, that would be 11. And you can go through all the other numbers, but those are the only two combinations that will give you 22. So we know we need to multiply to be 22 and add up to negative 23. Well, there's no way 2 and 11 can ever add up to 23, so we'll use 1 and 22. Okay, so let's think about this. The fact that we have to multiply to be a positive 22 on top tells me the two signs have to be the same, because the only way to get a positive number is either do a positive times a positive or a negative times a negative. So since I have to multiply to be positive 22, my two signs have to be the same. So now let's think about what we have to add up to. We have to add up to negative 23. Since we have to add to a negative number, we need them to both be negative. Negative 1 plus negative 22 does in fact add up to negative 23, and negative 1 times negative 22 multiplies to be positive 22. So x minus 1 and x minus 22 make our factoring for us. Okay, x squared minus 5x plus 6. Now this one's a little tricky, so please make sure you're paying close attention. There's no greatest common factor to pull out, so I go straight to setting up the two binomials. X is going front. I need to multiply to be 6, and I need to add up to a negative 5. Okay, so 6 can either be 1 and 6 or 2 and 3. 1 times 6 and 2 times 3. So here's the tricky part. Both 1 and 6 and 2 and 3 can be made to add up to negative 5. Okay, so let me show you what I'm talking about. If we use 1 and 6 and then make it a positive 1 and a negative 6, well, that does check out right here. 1 plus negative 6 is negative 5. However, 1 times negative 6 is not positive 6, and we need it to be positive. So this doesn't happen very often, but every now and then there are two pairs that will add up to that middle number, but that doesn't mean they'll both multiply to be the last number. In fact, that won't happen. There's only one correct answer for these. But sometimes you may just see, oh, there's the one that adds up, so that has to be right. But it's actually not. So 1 and 6 don't work. We've got to back up and try again. So instead of using 1 and 6, because they don't multiply to be positive 6 like we need them to, let's use 2 and 3. So for 2 and 3 to add up to negative 5, they would both need to be negative. Negative 2 plus negative 3 is negative 5. And negative 2 times negative 3 is positive 6. So that is the pair that works. Negative 2 and negative 3. Now that's another time that it's important to check your work if you're not sure. You can FOIL right here and you can make sure this is the same, and it is. If we had stuck with our negative 6 and positive 1, when we multiplied it back out by FOILing, we would have seen it didn't quite match because the signs would have been different. Okay, and that completes our trinomials. Be sure to come back for the next lesson, Ultimate Factoring Series, trinomials of the form ax squared plus bx plus c.